Okay, I'm going to talk to you a little bit about section 3B, accuracy and precision when measuring. So we start out talking about the natural idea that there are limitations when we measure. And there's some specific ways that we are limited. So your book mentions several. Here are 4 of them. First of all, we have instruments, but sometimes their markings just aren't perfect. They're man-made, even if they're machine-made. Those machines were made by man, so they aren't always perfect. Of course, our environmental conditions might interfere with making our measurements. So this picture is a pretty extreme environmental conditions, but you might want to think about measuring birds' wings in the Amazon. Okay, it's going to be difficult to try and get there, and once you've got the bird captured, it's going to be harder to make those kinds of measurements depending on where you have to be to make them. Another thing that can happen is the person observing might read incorrectly what the instrument says. And in other cases, our instrument might be damaged or have defects, and we may or may not realize it when we're making that measurement. And all of these issues are sources of error. Okay, we get error. Error is when our measurement is not exactly what our actual value is. The bottom line is all measurements, that's right, every single measurement ever made has some degree of error, and that has to do with something we call accuracy. Accuracy is how we look at error. Accuracy tells us about how much error we have, and that's always compared to some standard. And in some cases, standards have been established and decided upon. In other cases, you have to measure the standard first. But it's also tied to another concept, which often is used synonymously or in the same way, but is actually slightly different, and that's precision. So accuracy is this idea of error, how off are we from a standard. Precision is talking about how sure we are or how certain we are about a measurement. Remember, measurements and data that we communicate, we want it to retain its meaning and its certainty. Precision here talks about how certain we are. And precision depends on what kind of instrument we use. I'm not talking about a trumpet or a saxophone or a piano. We're talking about instruments that help us measure things. So rulers, thermometers, balances, that sort of thing. So depending on how precise your markings are or how many markings you have on your instrument, that's going to tell you how precise your measurement is. So there's also a little bit of a tricky thing to take into consideration, and that is what happens when you calculate something. So if you take 2 measurements and then you do a calculation with those measurements, there's an extra thing that you have to keep track of. Okay, so here I've pulled up my calculator so I can do this calculation here. We want to find the density of quartz. Quartz is this crystal here. Alright, it looks a lot like diamond. People wear it as jewelry. It's a little bit cheaper than diamond. We want to find its density. We're given the mass and the volume, and we know that density is simply mass, so 27.55 grams divided by volume, divided by volume, which is 10.4 centimeters cubed. And there is our solution. So our calculator tells us that the density is 2.6490384615384662. That is a lot of digits, okay? It turns out that when you see these digits, you might have an intuitive just sort of impulse that that's too many digits. Okay, what we started with were 4 digits when we're talking about the mass and 3 when we talked about the volume. For us to be that sure about this calculated answer just seems wrong. So what you would write on your paper normally, you might just guess. You might write 2.6 or you might write 2.65, or you might even write 2.649, depending on what your teacher may have taught you. So we're going to talk in the next section about how to decide how many of those digits to keep, but just know that that number of digits is related to this idea of precision. Okay, so now there are some things that have infinite precision, or things that are infinitely precise, and those are defined quantities and numbers or counting. So a defined quantity would be like 1 meter equals 100 centimeters. Okay, that's exact. There's no question. It's not 1 meter equals 100.00 centimeters. It's exactly infinitely precise 100 centimeters by definition. And then in numbers and counting, we've talked about this before. If I count the number of students in the room, I can't get 12.2 students, okay? It's going to be either 12 students or 13 students, but not in between. So those are both types of numbers that are infinitely precise. Okay, so how do you tell how precise to be? Okay, how do you decide how precise to be when you're using an instrument? Well, here's the answer. You always measure to 1/10 of the smallest decimal subdivision. So that means 1 decimal place past the value of your smallest markings. So here's an example. At the top here, I have a centimeter scale. Okay, I don't have millimeters marked out. So if I'm looking here, I know that this red line is at least 5 centimeters long, and it's less than 6, okay? But I don't have markings in between to tell me exactly where it is. It appears to be less than 5.5. So if I'm going to guess here, I'm going to say, okay, so we know that it's 5. I'm going to estimate one more digit. So following here what this says, okay, 1/10 of the smallest decimal subdivision on the instrument. Well, here the smallest decimal subdivision is a centimeter, so I'm going to measure to 1/10 past that. So my estimation here would be 5.4 centimeters. Okay, that's okay to estimate that last digit. Okay, that doesn't make it wrong because you're estimating. All right, now we're measuring this line again using a different kind of ruler. You'll notice this ruler not only has the centimeters, but it also has the millimeters. Okay, so this time you're going to again estimate to 1/10 of the smallest decimal subdivision. Well, here it's millimeters, so I'm going to estimate 1 past that. Well, I can zoom in and see, okay, this red line is definitely past the 5.3 mark. It's not quite to the 5.4 mark. Well, is it right in between 5.3, 5.4? Is it a little bit closer to one side or the other? It looks pretty close to in between. So you might estimate 5.36. It would totally be valid to also estimate 5.35. Okay, so there's room for different answers in this kind of problem. All right, so whenever you're using a ruler, thermometer, balance, whatever it is, you're going to write down all the digits that you know, meaning all the digits you can read directly from the instrument, and then estimate one more digit. All right, sort of an overview of accuracy, what accuracy and precision each look like. This is sort of a typical diagram we use. So accuracy, okay, high accuracy has to do with being close to some target, so some actual value. And precision has more to do with your measurements being close to each other or repeatable, okay? So if we take a look here at accuracy, when there's high accuracy, the average distance is pretty close to the center, but we see here in this case, with low precision, even though if you look at an average, these are all kind of close to the center, they're sort of spread out, okay? But if we had high precision and high accuracy, not only are the darts close to the center, but they're actually close to each other as well. They're all right on target. Okay, when our precision is low, that means that our measurements are all spread out. It's really hard to repeat them and figure out what they all mean. And so in this case here, if we have low precision and happen to have low accuracy, not only are they spread out, but they're not even, averaging close to the center. Or in some cases, we have high precision, but low accuracy, meaning all of our measurements are really close to each other, but they're not getting close to what it's supposed to be. And a lot of times, if several people are reading the instrument wrong, or maybe something's wrong with the instrument, they don't realize it, that this can happen pretty easily. All right, so that's a diagram you want to keep in mind when you're trying to think about what accuracy and precision are, compare and Okay, so let's talk about why accuracy and precision are important. So we heard from our guest speaker, Iris, about how she used GPS to help map some land in Tanzania and how that actually can be used in other places as well. So it turns out that we can use GPS all over the world. It's actually our government who pays for it, the satellites. And the way it works is a radio signal, okay, travels between a GPS device and several satellites. And using how long it takes for those signals to travel, you can figure out where you are, okay? So knowing the time and the speed of light allows you to solve for the distance. Now, there is a bit of error involved in GPS, and if you've ever used a GPS device, you might have seen that, okay? So it might be able to tell you that you're at your house, but maybe not what room in your house you're in. Though they are getting better and better. Where is that from? Well, these radio signals are traveling, okay, from Earth to space and back. It turns out there's stuff in between in their way, so they're having to travel through clouds and maybe birds or different things, and that kind of slows them down, and so that can give you a little bit of error. But as long as your use of the GPS is okay with an error of maybe 5 to 10 meters, you're okay, which for I think most of our purposes, driving from one place to another, that's not a big deal. It turns out you can also use geocaching for something kind of fun. Did I say geocaching? Sorry. You can use GPS for something kind of fun called geocaching. So I'm going to let this video introduce that to you. Okay, so that's just something fun you could do if you have a cell phone or another handheld GPS device. And I'm actually going to offer you a little bit of extra credit. I'm not going to announce this in class, so only if you're watching this video do you know. If you go geocaching and document it with some photos, you can email those photos to me before our next test. And I'll give you up to 1 point per geocache that you find, up to 3 points. So just email me photos of you and send me the log of where it was at. If you don't want, I'm not asking you to post these photos online, so you don't have to show your face online or anything like that. And you know, if you will log into the geocaching website and log it, you can send me a screenshot of that. But if your parents would prefer you not to do that, that's fine. Please don't tell anyone unless they already know about this, okay? So don't talk about it in class. But if you do have questions, you're welcome to email me or come talk to me after class, and I'll give you a few more details. All right, so the last few topics here are really things that you have to practice to become good at. So there's conceptual ideas I'm going to go over in this video, and then part of the reason I'm making this video is so that in class we can spend time practicing these things. So This first one is this idea of significant digits. Okay, so what does the word significant mean? All right, significant digits, digits that matter. Okay, digits that mean something.